Alright, so today we will be doing Unit 5, Lesson 4, which is Systems of Equations and Inequalities. And we'll be specifically looking at graphing inequalities on a coordinate plane. So here's the standard that we're going to be referencing in this lesson, which should be graph the solutions to a linear inequality in two variables as a half plane, excluding the boundary line in case of a strict inequality, and graphing the solution set to a system of linear inequalities in two variables as the intersection of the corresponding half plane. So this makes it sound a lot more confusing than it really is. The standards always do, but that is the standard. Alright, so a solution to a linear inequality, all of the ordered pairs, aka points on the graph, that make the inequality true. So that's what we define as a solution to a linear inequality. All of the ordered pairs, points on the graph, that make the inequality true. Everybody got that down? Points and true are the blanks. It says points. Okay, sounds good. Let's move on. All right, so determine which ordered pairs are solutions to the following inequalities. So this is actually a pretty easy procedure. You guys will, not find it too bad, I don't think. So what you're going to do is you're going to rewrite the equation, but instead of putting in y and x, or x and y, you're going to put in the ordered pairs. So I just left x and y blank. Now which ordered pair corresponds to x? 2 or 5? Which one, you guys? That's why we have to do the graphing robot. Which one's x, which one's y? 2 or 5? Thank you. There we go. Okay, it took a really long time. I mean, this is stuff you guys probably learned in maybe 6th grade, so let's get it. All right, so one is x, one is y, right? Okay, so this is x, and this is y. We plug them in for x and y. All right, we just plug them in. Now we're going to simplify. So what's 2 times 2?
4.
Thank you. What is 3 times 5?
15.
Good. So 4 minus 15, what's that going to be?
Negative 11.
-11. Somebody turn their music down. It's going to be in the background of my video. Thank you. This is... Well, wait a minute. This is true. True, yes. True.
I don't know.
So the answer here is true. -11 is less than 15. So yeah, for a second you're thinking they're not equal because you're used to doing equal, but no, it's an inequality. So, any questions about how to do number 1? So we're going to take this equation and we're going to plug in the points. So you're going to rewrite the equation, but you're going to leave x and y blank. Now, which one of these is x? -1 or -7?
-1.
Good. And which one is y?
-6.
Good, thank you. So we're going to plug in for x, we're going to plug in for y, and then we are going to simplify. So what is 2 times -1?
-2.
Good. And then what's a -3 times a -7?
-21.
Positive 21. Do you see why it's positive?
Because it flips.
Not because it flips, because they're both negative signs, so a negative times a negative is a positive. So that's 19 is less than 15. Is that true or false?
False.
Good. No, this is false.
Wait, is this all we're doing?
Today,
Then
for the most part. There's one other thing we're going to talk about, graphing, but it's not too bad. So any questions about number 2? All right, so let's do number 3. So for number 3, we're once again going to be plugging in for x and y. So you're going to rewrite your equation, or inequality in this case, but you're going to leave x and y blank. So what's your x in this case?
3.
And your y?
-1.
Good. Then you're just going to simplify. 2 times 3 is?
6.
6.
Good. -3 times -4?
Positive 12.
Good. What's 6 plus 12?
18.
Is 18 less than 15?
No.
No, this is false. So does everybody understand the concept of these?
Yeah.
Okay. All right. Next one we're looking at is 0, 0. So we're going to take our inequality and we're going to plug in 0 and 0. So 0 times 2 is what?
0.
Good. So we have 0 minus 0 is less than 15. What's 0 minus 0?
0.
So is 0 less than 15?
Yeah.
So this one is true, yes. Do you guys have any questions about this?
Number 3 was false or true?
It was false. The next thing, which is graphing linear inequalities. So you always write your inequality in what we call slope dash. Anybody know the next second word?
Intercept.
Good, intercept form. So you always want to write your inequalities in slope intercept form. You're then going to graph the line starting at the y-intercept b and then use the, what does m represent? So if b is the y-intercept and we're using slope intercept form, what must the m be?
X-intercept.
No, like the slope. But yeah, good guess. I see where you're going with that. So then it says to plot the additional points. So that's the main step that you're going to use. And then you're going to determine the type of line and where to shade. So these are the 4 symbols you're going to approach. Y is less than, y is greater than, y is less than or equal to, and y is greater than or equal to. So those are the 4 types of situations that you're going to see when you graph an inequality. Now, here are the type of lines that you use to graph these inequalities.
Wait, didn't we already do this?
Kind of, but not quite. We didn't really graph them, we just actually solved them. So you're going to use what we call a dashed line for this one. So you're going to draw a dashed line. You're going to use a dashed line for this one as well. And then for these 2, you're going to use what we call a solid line. Okay? So can anybody tell me like the connection here? Like why are the first 2 dashed and the second 2 solid? Anybody can notice why they would be that way?
Because they're greater or equal to.
Good. So yeah, see how the 2 that are solid have the greater than or equal to, and the 2 that are dashed do not have the equal to part. So the way that I help students try to remember this is, see how you use more ink to write a greater than equal to or less than equal to sign? Just like you use more ink to draw a line that doesn't have dashes in it, right? Here you would use less ink and less ink on your pen, or less lead on your pencil. So that's kind of a way to remember it. So now we're going to talk about shading, where we shade on our line. So we'll draw a little dashed line here. I should probably do it in red so I keep it consistent here. So we're going to draw a little dashed line here. And then for these 2, you're going to use what we call a solid line. So these are the 4 symbols you're going to approach. Y is less than, y is greater than, y is less than or equal to, and y is greater than or equal to. So that's kind of a way to remember it. So now we're going to talk about shading, where we shade on our line. So we'll draw a little dashed line here. So we have our little dashed line. It's going to look diagonal usually. And on this one, we're going to shade below the line. So you're going to put some little shading. So this is below is the direction here. Now on the next one, we have our little dashed line, which that wasn't even a dashed line. I don't know what I was doing there. Our little dashed line. And on this one, instead of shading below, we're going to shade what? Above. Now on the next one, we have our solid line. And on this one, we're going to shade below it. And if that one is below, what do you think this one is?
Above.
Above. So can anybody see a connection with the below or above? Like why are these two, why are number 1 and 3 below and why is 2 and 4 above? Anyone know?
Because for below it's like the y is less than.
Good.
So
Exactly. That's exactly. It's below, and then above. So on this one here, these two right here, see how it's less than, and this one's less than? When it's less than, you shade below. When it's greater than, you shade above. You guys see that connection there? Why these are the same and whatnot? Alright, so now we're going to do some examples together. And then you guys will have a chance to work on the assignment. So does anybody need more time on this slide to get it down? And I can put it up later too if you guys need to see it in more detail. Alright, so let's look at our first example. So, the first thing we have to do on this question is we have to get it into slope-intercept form, okay? Slope-intercept form. So let's zoom in here. So to get it into slope-intercept form, we're going to subtract 2x on both sides. You have to get the y by itself. When you do that, you're going to be left with negative 3y, yes, less than negative 2x plus 15. So I always want to order it in a way that is like slope-intercept form. You want the x to go first. Now to get the y by itself, I'm going to have to divide by what?
negative 3.
Good, negative 3. So we're going to divide everything by negative 3. And then we're going to simplify. So this goes away. Now what happens when you divide by a negative over an inequality? What does your inequality sign do?
Flip.
Flip. Yep, you always have to flip it if you divide by a negative. Then what is a negative divided by a negative?
Positive.
Good. Positive 2/3 x. And then what is 15 divided by negative 3?
Negative 5.
Good, negative 5. So this is our slope-intercept form of the inequality, okay? So once we have that slope-intercept form, we're ready to graph it, okay? So the first thing you're always going to graph, this is the first thing, the negative 5. So you're going to go down 1, 2, 3, 4, 5 units. That's where you start. And then you're going to go from there up 2 and over 3. That's your slope. So up 1, 2, over 1, 2, 3. So that's why we've been practicing graphing lines for like the last week, is because we're basically going to be doing the same procedure. Up 2, over 3. So up 2 more, over 3. Up 2, so 1, 2, over 1, 2, 3. And once you have that, you're now going to determine, is this line going to be dashed or solid? Based on what you just learned on the last slide. Dashed or solid? Dashed. Good. How do you know it's going to be dashed?
Because it's not the equal then.
Good. It doesn't have the equal underneath. Good. Exactly. So you're going to just graph this line. And it's going to be dashed. So you're going to put, like, when you do it with a pencil, just dash it. How did I get the what? Oh, the points on the graph?
Yeah.
Oh, you always start at -5, which is your slope, your y-intercept on the y-axis, to over 3, over and over again. And then, are we going to shade above or below? It's y is greater than. So according to your chart, is that above or below?
Above.
Above, good. So it's greater than, so it's going to be above. So you're going to shade up here. So that's how you graph an inequality. So you just shade that region in, above. Alright, so for the next one, I'm going to zoom in so that you guys can see the equation again. Better? So the first thing you're going to do is, this is what we call standard form. So I have to get it out of standard form into slope-intercept. So if you have a term with an x in it, you got to get it to the other side. So you're going to subtract the term with the x. And this is going to become -2y is greater than or equal to -5x plus 12. The 12 is positive, the 5x is negative. Then you are going to divide every term by what's the coefficient of y. This is going to cancel out, and you're left with y. And we divided by a negative, so when we divide by a negative, what do we do with our inequality sign? Flip it. So it's going to get flipped, because we divided by a negative number. Only when you divide by a negative number do you do that. Now a negative divided by a negative is a positive, so it's positive 2/5 x. And then what is 12 divided by -2? Anyone? Half of 12, guys. Thank you. -6. So once you have that, this is what we call our y-intercept, and this is our slope. So once we have that, we're ready to graph it. So I zoom out, and I can graph it. So you're going to start at your y-intercept, which is -6. You always start on this axis right here, the vertical one. So I go down 1, 2, 3, 4, 5, 6 units. So 1, 2, 3, 4, 5, 6 units. And then the slope tells me where to go from there. So we're going to go up 5 units. 1, 2, 3, 4, 5.
Over 2.
Good, over 2, 1, 2.
I sounded so sad when I said that.
Up 1, 2, 3, 4, 5, and over 1, 2. And then you just do this until you run out of space. 2, 3, 4, 5. Yes, I can get you a ruler. Here, come up, I'll grab you one. If anybody doesn't want rulers, I'll have some.
Yeah.
You guys can come get some if you want them.
I'm a little when it comes to doing
This line, is this line going to be solid or dashed?
Solid.
Good. Does everybody see why this line is solid? Yeah. It has the equal sign underneath. You guys have to know when it's dashed or solid. That's going to be on the quiz, okay? Quiz is next week. Wait, actually, technically it's the week. It's the 28th. Or the 27th or the 28th. So then we're going to shade which direction? It's less than. So we're going to shade below. Good. So use that chart, and you can use that chart on the quiz too. You need that. So do we have any questions on 2 before we move on to the next slide? No? Alright, so these are the two that come up a lot, and you have to know how to graph these. So these are actually a bit easier if you know how to do it. So whenever you have y is less than, greater than, or equal to a number, this is what we call a horizontal line. So is horizontal left to right or up and down?
Left to right.
Left to right. So you start on -4. So 1, 2, 3, 4. And then from there it's going to be a horizontal line. Now is this line going to be solid or dashed?
Solid.
Good. How do we know it's solid? Because of the inequality. The inequality tells us it's solid. So use the chart when in doubt. You're not sure? Use the chart to tell. And are we going to shade above or below?
Below.
Good. Shade below. So, any guesses? If this y is less than or greater than or whatever it is to a line, then what do you think x is going to be? If it's horizontal for the y, it's going to be
Vertical.
vertical. Good. So vertical lines are up and down. So you go to 7 on the x-axis. So 1, 2, 3, 4, 5, 6, 7. Is this line going to be solid or dashed?
Dash.
Good. And in this one, you can't really shade above or below. So if y is greater than x, am I going to shade to the left or to the right? What do you think?
Left.
So if it's greater than, where are the bigger x values? Where are the bigger x values, on the left or the right?
The right.
The right. The bigger values are over here, so you're going to shade to the right. Y is greater than 7, that's values bigger than 7. Shade to the right. So that only is an issue when it comes to where you have like a vertical line. Greater than is to the right, less than is to the left. So that's really only an issue with that one type of line that you have to know that. But you can kind of just think about it logically.